Class. Today we are going to be going through section 4.3, computations and other number bases. And like much of chapter 3 and chapter 4, we're not going to get real in-depth in this. We're only going to be adding and subtracting. We're not going to be multiplying or dividing in these other bases. If you want to do that sort of stuff, that's more like math major sort of topics. But I think again, one thing I like about this 4.2 and 4.3 is by exploring other number bases, I think we get a little bit better appreciation for how to work in base 10. And I kind of think that like the setup on how to add, subtract, and other number bases is going to take longer than the actual process itself. So there's sort of some background information we have to go through. But I think once we get through that and do a couple examples, hopefully this will be a little bit straightforward. But the biggest single thing in 4.3 to be successful is all your life you've worked in base 10. You know, you've worked in groups of 10, powers of 10, you know when to borrow, you know how to carry, all that sort of stuff, but it's always been with tens. Now we're going to be doing that with eights or fives or twos or fours or whatever our base is. So that is going to take some a little bit of flexibility is you're going to want to go back to like carrying 10 and borrowing 10 and like using digits that are base 10 other than their other bases. But the nice thing about this, the process of adding, subtracting works like we expect, other than, the different size groups. Okay, so let me, as always, get into the notes. These are on Blackboard, so we need to bring that up. Let's just go ahead and start. And I will also mention that in MATLAB, there's only 8 homework questions, like 4 or 5 add, and then the other are subtract. So again, this is, like I said, I do think this will take longer to, like I said, to set up and explain the first couple than it will be for you to actually like do the homework once you get rolling. Okay. So yeah, so yeah, there's a whole page of word notes here, and then some on the next column before you even get to the problem. So that's why I say the setup is kind of long here. Right. So just a few different things. So the main difference between add, subtracting and base 10 versus other bases is we have less digits to use because we're all our bases that we're going to be dealing with in the homework are less than base 10. We're not dealing with hexadecimal, which is base 16, or Babylonian, which is base 60. And so what I mean by that is, if we're doing binary, which is base 2, we're only using the digits 0 and 1. Octal, which is base 8, we're using 0 through 7. And base 5, we're using 0 through 4, and so on. And so what this means, like if you're doing a base 2 operation and your answer has anything other than a 0 or 1, that should be a red flag that you're not in base 2. If we're dealing with base 8 and you get an 8 or a 9 in your answer, then that should be a red flag because we should only go up to 7, and so on. The other thing about this is, when you think of adding or counting up, when do you go over to the next higher place value system? Well, it's when we hit groups of 10. And so, 6, 7, 8, 9, those are all single digits, but then as soon as you hit 10, that's when you have to go over to the tens place value. And if just, when we have 10, that is not a single digit. Now that is a 1 and a 0. What does that mean? That means 0 ones and 1 10. And so when we're counting up in other number bases, when you go over to the next higher place value is when you get to that base. So for example, if we're in base 8, counting up, you're gonna have 5, 6, 7. But when you get to 8, 8 is one of our place values. So we need to take that 8 to the next higher place value and have 0 ones. I don't know when to do manipulatives, but let's do this with some dice. And don't worry about the numbers on them. I'm just, if little dice are the place value you're in, the bigger dice will be the next higher place value. So if we're counting in base eight, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now once we get to 8, well, we're in base 8. So what we have to do is take those to the next higher place value. And so we have 1, 8. And then how many ones do we have left? None, because all 8 ones became the 8 place value. And by that, I mean, so all base number systems have that place value of 1, because that's 8 to the 0, 2 to the 0, 10 to the 0. And then for base 8, the place values are going to be 8 to the first, 8 to the second, 8 to the third. So instead of the tens, hundreds, thousands, now we're going to have the 8s. 8 squared is 64, and then 8 cubed is 512. So that's what we're going to have instead of 10, 100,000. If we're dealing in base 5, if we're counting up, so 1, 2, 3, 4, 5. But once we hit that 5, which is our base, that 5 ones becomes 1, 5. Let's say let's say that we have, let's see what is that, 8. So we're in base 5 and I have 8 ones. Well, what's the, we can't have 8 ones because our digits only go up to 4 in base 5. So what we do is we take 5 of those ones, those become a 5, and then we have 3 ones left over. So it doesn't matter if we're in the ones place value or the fives place value or the 5 squareds place value. Once you get to where you carry over to the next higher place value, you subtract however what your base is to see, that's going to go over here, and then what you have left over is in the original place value. So for example, let's see, there is. So let's say that I'm in base 4 and I have 9 ones. Well, I can't have 9 ones in base 4 because 9 is we can't have digits 4 higher. So what do we do is there is a 4 that becomes over to the next higher, the 4's place value. There is a second 4 that goes over to the next higher place value, and we have 1 left. So if I had so if I had 9 ones in base 4, what that is equal to is now we have 2 4s. So 2 times 4 to the first, and then 1, 1. That sort of, that we're going to have to get used to doing this expanded place value for bases other than 10. So if this didn't make a lot of sense, I apologize. I just wanted to try something a little bit different, but we're going to do a lot of examples on this. But this is like getting this idea of like when do you carry over to the next higher place value is sort of the key to this unit. Okay. We're going to visit that in a lot of different ways. All right. And again, just for emphasis, we're going to have to be doing place value and other number systems. Remember, place value is based on powers of the base. So every single number system is going to have a ones place value because you're going to start with 2 to the 0 or 8 to the 0. Your first exponent is always going to be 0. Anything to 0 power always gives you 1. So it's always our rightmost place value number, no matter what the base is. Then as you go to the left, increase your exponent by 1. So if we're in binary, which is base 2, we're going to have 1s to the first, to the second, to the third, to the fourth, and so on. For an octal, which is base 8, we're going to start with 8 to the 0, which is 1. Then as you go to the left, it's going to be 8 to the first, 8 to the second, 8 to the third, and so on. If we're in base 5, then the place values on the right are going to start the 1s, and 5 to the first, 5 to the second, 5 to the third, so on. So if you've done section 4.2, you should be at least sort of familiar with what I'm talking about here. If you haven't even looked at the homework for 4.2, I would actually probably recommend that you stop right now with 4.3, go back and do 4.2 and convert between your number bases, because that will make this part make a lot more sense. All right. And don't forget on the notation with other number bases that we are using the subscript for the number base. What else? Yeah, so let's at this point, let's just gonna, yeah, that's kind of a review of 4.2. So let's go on to the actual adding subtracting. But like I do want to emphasize that adding subtracting and other number bases works like you normally are used to in base 10. It's now we're not working in groups of 10, we're working in groups of whatever our base is. There are two ways that you can do this. Okay? One, you can add or subtract in the given number base. So if we're in base 4, we're going to add subtract to base 4. If we're in base 5, we're going to add subtract to base 5, and so on. If you don't have to borrow or carry, that is like I don't usually like to use the word easy, but those are easy because if there's no borrowing carrying, it works exactly like you do in base 10. Okay. Without the borrowing carrying, these are straightforward problems. If you have to borrow and carry, then what we have to be careful of is we're borrowing carrying on groups of that base, not groups of 10. So if we're in base 8, when we borrow and carry, we're borrowing carrying 8s, not 10s. If we're in base 5, we're borrowing carrying groups of 5, not 10. Or if we're in binary, which is group 2, base 2, we're adding subtracting groups of 2, not 10s. So that is going to be a very common mistake on this. Is you've been doing base 10 all your life with adding subtracting, and so you're gonna when you put those ones when you borrow and carry, that's because we're adding subtracting 10s. Now we're gonna have to add subtract 5s, add subtract 8s, and so on. So that is how I'm going to do all these problems today. If this borrowing carrying really throws you off, you could actually convert your numbers to base 10 before you do the add or subtract, then add subtract as normal because you're used to doing it in base 10, but then you have to convert your answer back to what the starting base. So this is definitely not very efficient because you have to basically do 3 converting problems all in one add or subtract problem. But it's the long way, but it works, and it lets you borrow and carry as normal in base 10. But I definitely want you to try to get used to borrowing and carrying in other number bases. This is sort of like when we were dealing with mixed numbers. For abstracting, we said that if the numbers were nice, you could go ahead and abstract mixed numbers, but like the denominators were different. If you had to borrow or carry, you might want to just automatically go to improper fractions, deal with improper fractions and then convert it back. That's the same sort of idea, but I think it's a bit messier when you're converting number bases than it was converting back and forth between improper fractions and mixed numbers. Okay, but that is the backup plan if borrowing, carrying, and other number bases isn't working for you. Is you can always do what you did in 4.2, convert it to base 10, and then all right, so just other couple things to keep in mind. We're only going to be adding 2 numbers at once. And since you're only adding 2 numbers, think of it in base 10. If you're adding a, 9 plus 9 is the biggest you could get for single digits, which would be 18. You can never get to 20 with just 2 one-digit numbers. And so when we borrow or carry, particularly with carry, we're only going to have to carry 1 at the most. We're not going to get in the 20s or 30s or whatever and have to carry a 2 or 3. So when we're carrying, it's either we don't carry at all or we're going to carry just a 1. So that'll simplify the problem a little bit. Definitely make sure when you're adding that you always start in the ones place value, work your way to the left, because if you have to carry, you have to do that first before you can do the next addition. So this works just like with normal addition. Start on the right, work your way to the left. Okay. And then if we do have to borrow, the reason that you have to carry, because we're adding, I'm sorry, not subtracting right now. So if you're adding, once your sum hits the base or higher, that's when you have to carry 1 over. And then what you have left in that column is subtract your base. So if you're in base 5 and you add up to 8, I did this before. So if we if we're in base 5 and our sum is 8 in the ones column, you have to take 5 of those, carry them over, carry them over to the next higher one. And then once you take those 5 away, you have 3 ones left. Or if you are in base 5 and your sum adds up to 6, then 5 of those go over to the next higher place value, become 1 of the next higher place value, and you have 1 left over. Same way, if you're in base 5 and the sum adds up to 5, those 5 are going to carry over, become 1 of the next higher one, and then you have no ones left. So you'd have a 0. So that's what you have to look for when you're adding is, does that number add up to the base or higher? If it does, you have to carry it. All right, so let's just jump into this and see how this works. All right, so we're adding 301 in base 4 to 12 base 4. Oh, by the way, we're never going to mix bases. You're not going to have like a base 4 and a base 5 problem. So don't worry about that. And again, we're only going to have 2 numbers to add. All right, well, start on the right and work your way to the left. So 1 plus 2 is 3. Yeah. Is 3 good? Yes, because we're in base 4, so we can have anything 3 or lower. Then go to the left, 0 plus 1 is 1. And then bring down to 3, because it's basically 3 plus 0. And notice that none of these columns added up to 4 or higher, which is our base. So we didn't have to worry about carrying. So that is actually our answer. I'm always using numbers for my subscripts instead of writing it out. That's what I'm used to. It's way more efficient. So if you don't have to carry over, addition is really quick. Just add them up. Okay, for base 4, there's nothing bigger than 4. We're good. All right. How about the next one? So 32 base 4 plus 10 base 4. Well, 2 plus 0 is 2. That's not 4 bigger, so we're fine. Go to the next column. 3 plus 1 is 4. Okay, now we have a problem. This can't be 4 or higher. So what that means is we need to carry. So we are base 4. So 4 in base 4 is sort of like 10 in base 10. So what we're doing is our sum was 4. We're in base 4. So one of those 4s has to get carried over into the next higher column. So there's one of those, and how many? In this case, it's the 4s column, because that's the second column. There are no 4s left, but there is a 4 to the second. So remember, in base 4, our place values are 1, 4 to the first, 4 to the second. Okay, so we said there are 4 1s, but we can't have 4 of them, or sorry, 4 4s. So we can't have 4 of them. So what that means is now we're going to make that a 0. And carry the 1. It gets a little messy. I'm going to rewrite the number here. So there's 2 1s. There are now 0 4s. And then we carried the 1. So it's 102 base 4. So basically a 4 becomes a 10 in base 4. Like a 5 becomes 10 in base 5. A 6 becomes 10 in base 6, and so on. I don't know. I don't know how messy that gets, so let's just keep doing examples. But the key on this one is the first column we didn't have, the sum was less than 4, so didn't have to worry about carrying. Here we had a sum of 4, so we had to carry. All right, let's do number 6. Okay, we have 342 base 5 plus 343 base 5. So our place values, so our place values for base 5. Start on the right. It's always, first one is always the 1s. Then it's 5 to the first, 5 to the second, 5 to the third, and so on. So we have the 1s, we have the 5s, the 25s, and the 125s. And when we're looking at this, just look at our columns. So we're going to have a 2 plus 3, which is a 5. We're base 5, so that means we're going to have to carry. That second column is going to have a 4 plus a 4, and don't worry about the carry at the moment. That's going to be higher than 5, so we're going to have a carry there. And then 3 plus 3 is 6. That's higher than 5. So every single one of these columns already is going to have a carry. All right, so how do we go through and do this? So 2 plus 3, we would say is 5, but we're in base 5, so what do we do with that? Well, we carry, so we have our sum came out to 5. So what that means is that 5, we have 5 ones, take those 5 ones and make them 1, 5. Now, how many do we have left over? None, because we took all 5 off. So if you want to know the leftover is you subtract your base. So 5 is equal to 10 in base 5. So 5 in base 10 is 0 ones and 1 5. So we put a 0 there and then carry the 1. So every time we get a group of 5, we're going to have to carry it on. All right, now look at the second column. We're going to have 1 plus 4 plus 4. So that's going to give us a 9, but 9 is more than 5. So we're going to have to carry. So how much do we carry? So we have 9. Now remember, right now we're in the 5s group, but it doesn't really matter which place value you're in. The carrying still works. So we have 9 5s. 5 of those is going to get carried over to the next higher place value. So we come up here, put a 1. And then how many do we have left over? We have 4. So we put a 4 in that second column. Okay. So since we're in base 5, we're subtracting 5 from whatever our sum is to see how much is left. All right. So now in the last column, we have 3 plus 3 plus 1. So that's going to give us 7. 5, 6, 7. And so we're base 5. So 5 of those goes over to the next higher place value. So now we have to do another carry. And then we have 2 left over. So that 2 is what goes in the third column. And then we carried 1 over. And that became the next higher place value. We have 1, 2, 4, 0, base 5. When you put this in MATLAB, don't forget your base. All right, so kind of a summary. So you have to carry, when you're adding, you have to carry if your sum is equal to your base or higher. So it doesn't matter if it's base 5, if it's 5, if you get a 5 or higher. If you're base 8, when you get an 8 or higher. When it's binary, if you get a 2 or higher, you're going to have to carry. The carry, we're only carrying 1 at a time with the problems we're doing. So you put that 1 up there like you always do. And then to get what's left over, you have, normally it's just, if your sum is 11, you carry the 1, you have a 1 down here. Or if your sum is 26, then you carry the 2, have a 6 here. That's only for base 10. Since we're in different bases, you have to subtract that base from your sum to get the leftover. All right. So 2 plus 3 is 5. So we carried the 1, had none left over. 1 plus 4 plus 4 was 9, which is higher than 5. So we carried the 1. 9 minus 5 gave us the 4. And then we have 7, which is bigger than 5. So we had to carry a 1. And then 7 minus 5 is 2. And we bring down the 1. Again, this is where I haven't done this in class yet. So I don't know what questions students are going to be asking. So hopefully I'm kind of hitting all the highlights. All right, let's just keep doing examples. That's this way you have to get through this. All right, so we are doing 110 base 2 plus 11 base 2. So what are our place values? you don't really, I guess, need to know the place values, as long as you get for the adding anyway, in particular. But it's always starts with the ones. Now we're base 2, so it's 2 to the first, 2 to the second, 2 to the third, and so on. And so remember, if our sum comes up to 2, that's when we have to carry. All right, so first column, 0 plus 1 is 1, not 2 or bigger, so there's no carry. Now 1 plus 1 is 2. 2 is our base. So we have 2 in that column. What we have to do is carry those over. So it becomes 1. So there's a carry, right, in the third column. We're working on the second column. So there's a carries over to the third column. And what is left in the first column? Nothing, because the 2 we had became the next higher place value. So there is 1 plus 1 in base 2 is 0 plus 1, basically 10. So we got our 0, and then we're into the third column. So we have 1 plus 1, which again, 1 plus 1 is 2. Got to carry it over. So there is a carry into the fourth column, and there are no like ones left. So there's a 0, and then we have the last carry is 1, 0, 0, 1. So we started with a 3-digit number, added a 2-digit number, and this is where you kind of, just like with base 10, all those carries go one place value over. Don't forget your base 2. All right. Now, since this one's a little bit shorter, let me just kind of show you what would happen if all this barring and carrying isn't working for you. What you could do is convert. So 110 base 2. So this is where we need the place values of converting. So so that's the third one, so 1, 2, 3. So that would be 1 times 2 squared plus 1 times 2 to the first plus 0. So it would be 4 plus 2 plus 0, which is 6 in base 10. So, and then if we do 11 in base 2, that's the second column, so it'd be 2 to the first, so 1 times 2 to the first plus 1 times 1, so it'd be 2 plus 1, which is 3, base 10. So then you would add those together. So we get 9 in base 10. And then what we have to do is convert it back. And this is where if you haven't done 4.2, you definitely can't do this yet, because this is what we did in 4.2, the second half. And so remember, to convert it back, we need to figure out what those digits are in the place values. That's where we're going to do a bunch of divisions. And so if you go to your place values, you need the biggest place value that's not too big. So if we do 2 to the fourth, that's 16. 16 is bigger than 9. We don't want 2 to the fourth. 2 to the eighth, or 2 to the third is 8. And so let me do this on a different piece of paper. So if we're going to convert 9 base 10 to base 2, we're going to do a series of place value, series of divisions to figure out the place value. So this is basically a quick review of 4.2. So we're dividing 9, and we're going to divide by 8, because that's the biggest one that's not too big. So we're doing long division. We need the remainder, so that goes in one time. Remainder 1. Then what you do is you take that remainder. That's what's on the inside. And then you divide it by the next smaller one. So we divided by 8. Now we're going to divide by 4. Well, how many times does 4 go into 1? It doesn't, so that means 0 times with the remainder 1. By the way, circle the whole number answer. These are what's going to give us our answer. So now we take that remainder 1. That's going to be inside our next division. So what do we divide it by? We've already divided by 4, so now we got to divide by 2. Well, same thing happens is 2 goes into 1 0 times, the remainder 1. But once again, that 1 comes down. We're going to do division on 1. And what do we do division on 1 with? Well, we've already divided it for 2, so now we do divide with 1. Well, 1 goes into 1 once with no remainder. So that's it. And so our answer is these in order from left to right. So it'd be 1, 0, 0, 1, which is what we had before. So this is if the borrowing and carrying doesn't start to click for you, this is what you're going to have to do. This was a relatively short number because it was, well, base 2 tends to have more divisions. But this is kind of what you have to do. You have to, if you either have to borrow and carry in the base, or you have to convert both of those to base 10, do the add or subtract, and then once you have your add subtract, then you convert back. So I'm not going to do any more examples of that for these notes, but I just wanted to show one. All right. Excuse me. All right, let's do the we need to do example runs. Like I said, this is one of the more complicated things until it starts to make sense. Okay. So 2011 base 3 plus 121 base 3. Okay. So here 3 is the key. So if we get a sum that is 3 or higher, we have to borrow, or sorry, we have to carry. Not spread. So 1 plus 1 is 2. We're good. Let's see if I can. Where's my post? Good. So now 1 plus 2 is 3. The 3 is our base. So 3, base 3 is what we have to do is there are 3 in that column. So 3 of those will carry over to the next higher column. And then what do we have left? We have none left. So in that column, we put a 0, and then we carry 1 over. So 3 in base 3 becomes 0, carry 1. That's basically our 10. And like we had 10 at base 10, you'd have the 0 and then carry the 1. Same way with 3. Okay. Now look at the third column. We have 1 plus 0, which is 1. 1 is less than 3, so no carrying is needed. And then in the last column, we have 2 plus 1, which is 3. That is our base, so we're going to have to carry. So we have 3 of them. Those carry over to 1 to the next higher place value. There are none left. So there's going to be a 0 that we bring down because that's what's left. We carry the 1, so that 1 gets added on at the end. And that is our 5th column. Yeah, like I said, I really wish I could take questions here. But if you have questions and examples, and this isn't helping, please email me. We can set up a Zoom, or we can, or just contact via email. See if we can get you straightened up. Okay. Number 9 is base 9. So we have 8, 7, 6, 5 plus 5, 6, 5, 8, 6, 4. So when we're gonna have to carry is if our sum is 9 or higher. So first column is 5 plus 4, which is 9. Okay, so that's our base. So 5, 8, 9. So how do we carry? Well, 9 of those go to the next higher place value. And then how many's left? None. So there is a 0 there. And then we carry the 1. So now look at your next column. We have 1 plus 6 plus 6, which is 13. 4, which is definitely higher than 9, 8, 12, 13. All right, so what is 13 in base 9? Well, we need 9 of those to carry over. So 9 of those go to 1 in the next higher place value. How many is left over is 4. So in that column, you put a 4 and then carry the 1. Okay, so now we're at the next column. We've got 1 plus 7 plus 8, which is 16. So there is 9. There's 15, 16. Okay. So 9 of those carry over. So there's a carry. How many are left? We have 7 left. So we bring down a 7. Okay. Now that last one, we have 1 plus 8 plus 5. 1, 8, and then 5. Okay. Which that's definitely 9, higher than 9. So what do? Is we take 9 of them. So there's our 8 and our 1. Those carry over to the next higher place value. What do we have left in the current place value? We have 5. And so we bring down a 5, carry a 1. Well, now it's in our 5th place. We don't have any, that's the only thing we have in our 5th place. We just bring it down to be 15, 7, 40, base 9. So when you're adding, if your sum adds up to your base or higher, we're going to carry 1 over and then subtract that base to see like how many is left in that column. Hopefully I've explained that properly. All right, so that is adding. Subtracting, again, subtracting works as normal. You start on the right, work your way left. When do you have to borrow when you subtract? It's when you're trying to take a bigger number from a smaller number. And so all that still applies. The only difference is now instead of borrowing 10, because we're in base 10, we're going to borrow 8 if we're in base 8. We're going to borrow 5 if we're in base 5, and so on. All right. So let's just jump into this and see how it goes. So 11, we're subtracting 32 base 4 minus 11 base 4. So 2 minus 1 is 1. 3 minus 1 is 2. At no point did we have to borrow. So that's, if you don't have to borrow, subtracting is that easy. It's normal subtraction. It's straightforward with no borrowing is allowed. All right. Again, don't forget your base number. All right, how about 12? Okay, so we have 42 base 5 minus 13 base 5. So we're definitely going to have to borrow now because we can't take 3 from 2. So the first part of the borrowing works like we're used to. So we're going to come over here and borrow one of those and make that a 3. But now the question is, what did we just borrow? Well, since we're in base 5, remember our place values are going to start at 1 on the right. It's 5 to the first, 5 to the second, 5 to the third. So our place values are based on 5. So since we're borrowing in base 5, you're adding 5. We're not adding 10, so don't make that a 12. If you make that a 12, you're stuck in base 10. Okay, so this is actually a 7. Because we have the 2 that we had plus the 5 we borrowed. So now we have a 7. So now in our subtraction, we don't normally write this out, but let me write it out. We have 3, 7 minus 13. I'm not going to worry about the basis at the moment because once you start subtracting, just subtract as normal. And then when you have to worry about the base is the borrowing part. At the end, make sure you get the subscript. Okay, so now we don't. So now we have 7 minus 3, which is 4. 3 minus 1, which is 2. Base 5. So there's our answer. So this right here is the key step. So when you borrow, add whatever the base is. Don't add 10, add the base. We are still borrowing 1, so you're still going to subtract 1 from that number, just like you have since elementary. It's just this part is different. All right, let's go to the next one. 721 base 9 minus 473 base 9. So as I'm looking at that, we're going to have to do 3 from 1. That's definitely going to be a borrow. We're going to take 7 from 2, which, well, the 2 will change, but that's definitely, we're going to borrow twice on this problem. Again, you never have to borrow on the last one because we're always putting the bigger number on top. So, but borrow from left to right and see how this works. So we can't take 3 from 1. So we have to come over here and borrow. So cross out the 2, subtract 1, make it a 1. But now we're not adding 10, so don't make that 11. We're adding 9. So that becomes 721. I'm going to put a 10 there because that's 2 digits now. So what we're really doing is 10 minus 3 is 7. Okay. Now we go to the next column. We can't take 7 from 1, so we're going to have to borrow. So the next borrow is take 1 away from the 7, make that a 6. That works as normal. But now we're not adding 10, we're adding 9. We're going to do 9 again. So that becomes a 10 again. And so we're doing 9 minus 7, which is 2. And for that last column, we shouldn't have to borrow because bigger numbers are on top. So 6 minus 4 is 2. It's 9. Again, the key here is that we added 9. If we were in base 9. If you can kind of have that click over in your head to not add 10 to add the base, that's what it takes to be successful with subtracting in different bases. All right, let's do number 14. So 1 minus 0, well, that's 1. Don't have to worry about borrowing there, right? Now we're doing 0 minus 1, so we can't take 1 from 0, so we have to borrow. So you go to the next column, we're going to subtract 1 from the 1, make that a 0. Do not add 10, add 2. So now we're doing 2 minus 1, which is 1. Now for the third column, now we have, since we took 1 away from that, we're doing 0 minus 1. We can't take 1 from 0, so we got to borrow. So we go over here, subtract 1, make that a 0. Now we're going to add 2. It's probably like make this huge to make it a little bit easier to see. Okay, so now we're doing 2 minus 1, which is 1. And then for that fourth column, that's a 0. So 0 minus 0 is 0. So that is 111 base 2. Again, the key here is that we added 2 instead of adding 10. And that's it. We're not going to do, like I said, we're not going to do more than 2 numbers at once. We're never going to give you different bases to work with, because then you would have to, basically, if you had different bases, I would just convert them both to base 10 and then figure out what the answer is. And that would just be messy. Again, we'll leave that for math majors. But it's, if you don't have, when you're subtracting, if you don't have to carry, or sorry, if you don't have to borrow, it's normal subtraction. Works great. If you have to borrow because you're subtracting a larger number from a smaller number, as always, subtract 1 from the column you're borrowing from, but then add the base. We added 5 here, we added 9 here, we added 2 here. Do not add 10. That's where you're going to get in trouble. And if you're one of the ways you can see that you have a red flag is if in any of your answers, your digits are bigger than your base or equal to or bigger than your base, that most likely means you added 10. So like if you had like for example, if you added 10 here to the 2, made that 12, 12 minus 3 is 9. If you had 29 base 5, that should be a red flag that something is wrong because you couldn't have a 9 digit in base 5. The most common mistake is going to be adding 10. So if you have those digits that are too big, that should be a red flag. 9, the only digit we can't have is 8. So if you have an 8 in there, that would be a red flag. Base 2 is only zeros and ones. So like here, if you would have added on that one, if you would have added 10 to that one, 10 minus 1 is 9. You would have had a 9 in there. That should have been a red flag. So watch out for those digits that are outside the base. That's when you know that something is wrong. The subtraction, if you have those, like I said, that means you added 10 instead of adding the base. If you're adding and have like, the 3 or higher in base 3, what that means is you have to carry over to the next higher place value. Okay. That's it. Let me look at the math lab stuff right quick, see if there's anything. So let me go over there. So here's an example. Like I said, there's only 8 questions. Let's see, it's question 5 is subtract. So you have, I did give you 3. Looks like there's one problem with 3. So let's go ahead and do this one. After I told you, there was only going to be 2 at a time. Okay. All right. So this is question number 5. 4.3 homework. All right, so we have 11,011 base 2, and then 5 ones, 1, and then 11,011 again. All right, so now we're adding 3 numbers at once in base 2. So let's go column by column. The first column is 3. 3 is bigger than base 2, so we have to carry. So our sum is 3. I guess it would help if I go back to the camera. So notice that they had it written out horizontally. Anytime we're adding by hand, do it vertically, make sure they're lined up on the right so all our place values are the same. Okay. So when we add that first column, 1 plus 1 plus 1, so that is 3. We're in base 2, so we can't have a 3 in base 2, which means we have to carry 2. So 2 of those carry over to the next higher place value, and 1 is left. So you put a 1 in that column and carry a 1 in the second column. Now in that second column, we have 1 plus 1 plus 1 plus 1, which is 4. Okay. So that's definitely more than 2. So how do we deal with that? Well, the first group of 2 carries over. There's 1 that carries over to the next higher place value. However, we have another group of 2. So those 2 carry over to the next higher place value. So what do we actually carry? We carry a 2 into that third column. And then what do we have left? We have nothing left. So there's a 0 in the second column. So this is why I said if we're only adding 2 numbers, you'd only carry 1 at the most. But once you get 3 more columns, then you can start carrying more. Right. Now, normally we don't have a 2, and we can't have a 2 end up in base 2, but still carry a 2. So that way when we do the sums, we're doing our sums right. So this kind of intermediate step that we're kind of okay for the moment. And the reason we are is because now when you get to the third column, we have 2 To be fully correct, we should do more carrying, but we're not going to mess with that. Just since this is the one problem where you have to carry 2, then we'll just do that. So 2 plus 1 is 3. And so we have 3. So what do we do with 3 when we're in base 2? Well, 2, come over to the next higher column. So there is the carry. We have 1 left. So there's a 1 in that third column. All right, fourth column. Well, that gives us a total of 4. So we've dealt with this before. So we carry over 1 group of 2, 2 groups of 2. We're going to carry over 2. We have none left. Ooh, now we get a 5. So what is 5 in base 2? Now we're going to get really messy. I wonder if I should take this problem out. Right, so how do we do this? There's 1 group of 2, 2 groups of 2. So the next column we're going to carry over a 2, bring down a 1. So now we're into the 6th column. We have a 2. So what do we do with the 2? We carry 1 over and bring down a 0. And then that last column is a 1. So this definitely got messy because we were carrying over more than just 1. Right? So technically, we should have. Yeah, we only carry 1 column at a time, so we'll just stick with those 2s. All right. That is definitely a stretch your muscle sort of problem. This will not be on the test. On the test, you're just going to be abstracting 2 numbers. But sometimes I like to, in the homework, I like to throw in occasionally like 1 problem that's a little bit above and beyond. I think it makes, like now, if you just add 2 numbers, it'd make those a little bit more straightforward is the hope. All right, so you have 4 in MATLAB, you have 4 regular addition problems and 3 subtraction problems plus like the bonus problem. That's 4.3. That's all I have. As always, if you have any questions, please send me an email. We can either communicate via email or set up some Zooms. Otherwise, have a good day.